In this part, we will discuss what is stack and what is its purpose in 8051 microcontroller. Stack is a special section in RAM that is used by CPU to store information. Basically, this information can be data, it can be an address that is stored in this special memory area. So a register is basically linked with the stack, that is called stack pointer. Stack pointer register basically track the locations that has been utilized by stack. The stack pointer register is 8-bit register like other registers of 8051, which means it can take values between 00 to FF in hexadecimal, or we can say 0 to 255. When the 8051 is powered up, normally all other registers have 0 value, but the stack pointer register contains 7 value that basically indicate that the next location that would be utilized by stack would be 8th location of RAM. 7 also indicate that this is the last location used by stack. If a new data would arrive, it would be saved on 8th location. Basically, there are two main operations that are linked with stack. For example, if you want to store data in stack, then the push operation would be performed. In case of push operation, the stack pointer that is normally pointing to the last location that has been used by stack would be incremented. So whenever the push operation would be performed, the value of stack pointer would be incremented by 1. That will indicate that the stack has utilized one more location. Whenever we need to load the contents from stack or we want to retrieve back the data from the stack, it would be performed using pop operation, and in case of pop operation, the stack pointer would be decremented by 1. This decrement in stack pointers indicates that 1 byte has been removed from the stack and this location can be utilized again. So here we can see some examples that how data is pushed onto the stack. For example, here we can see that there are basically 3 instructions. Move R6, #25H. Basically 25H hexadecimal value is moved to R6 register. Move R1, #12H. In this case 12H, the hexadecimal value is moved to R1 register. That is basically RAM location 1. And similarly our hexa value F3H is moved to R4 register. That is basically on the RAM location 4. As we have mentioned in previous part, the push and pop instruction use direct addressing. We cannot use the name of the register. We can only use the address of RAM location. So whenever we will perform push 6, we are moving data from RAM location 6 that basically correspond to R6 register. So we can see that here we have 3 push instructions. Stack pointer is currently 7. As the first push 6 instruction would be performed, the value of R6 would be moved to 8th location of RAM. Stack pointer 7 is indicating that the next value that would be pushed would be placed on 8th RAM location. So after push 6 instruction, the 25 value that was on 6th memory location would be moved to 8 because of stack pointer. Now stack pointer has been incremented, its value has been increased. After this, when push 1 instruction would be executed, this 12H would be moved to 9th RAM location. Stack pointer has been incremented. It is indicating that one location has been further utilized. After the next push, push 4, now the next value that was on R4, F3 has been moved to A location. Now stack pointer has been incremented and its current value is A. If we talk about the example of data popping, in this case, we can see here the value of stack pointer is B. This B is indicating that the last value that was pushed in stack on this B location. So when the first pop would be performed, for example, after performing pop 3, this value would be moved to R3 register. Basically RAM location 3 correspond to R3 register. So as the pop would be performed, the B location would be emptied and stack pointer would be decremented by 1. This decrement is now indicating that if the next pop would be performed, the value that is present on A location would be provided. So after execution of pop 5 instruction, the value present at stack pointer's address would be provided. After pop 5, the value present at A location that was F9 would be provided to R5 register, and stack pointer has been decremented by 1. Previously it was 10, now it is 9. After this, when the pop2 instruction would be performed, the value that is present on stack pointer 976 would be provided to R2 register. So now stack pointer is at 8, that is indicating that if the next value would be pushed, it would be placed on 9, and if the next pop is performed, the value that has to be provided is present on 8th location. Another important concept is the upper limit of the stack from 8 to 1F, that is basically area of bank 1, bank 2, bank 3 is normally used for stack operation. Basically 20 to 28F, next 16 bytes are reserved for bit addressable map and must not be used by the stack. So if in a given program we need more than 24 bytes, more than these 3 banks for the stack purpose, we will have to move the location of stack. That can be done by replacing the value in stack pointer. For example, if we place 30H in the stack pointer and we will push the values, it would be moved to general purpose RAM. So basically this is stack. Stack is an important memory area that is used to store important data or instructions by the CPU. Thank you.